All right, it's time to start the session. Deep dive into Layout Manager for RecyclerView.
All right, let's get started. Thank you for coming to my session. The title of my talk is Deep Dive into Layout Manager for RecyclerView. Who am I? My name is thagikura. I work for developer relations at Google. I was born and grew up in Japan, but I wanted to contribute to make the DroidKaigi international. So let me give you this talk in English. If you don't understand, please raise your hand. Today, I'm going to talk about RecyclerView. Let me start off with a couple of questions. Now, how many of you have used RecyclerView before? All right, I think most of them. Then, how many of you have created your own custom layout manager? Very few of them. All right. I hope this session is for you, including all of you. I hope everyone here already have heard about RecyclerView. It's like a successor of ListView. Now, one of the characteristics of using RecyclerView is you can customize the behavior of it by changing the components attached to it. One example is LayoutManager, which I'm going to talk about. By changing LayoutManager attached to the RecyclerView, then you can change how the data is presented, regardless of the underlying data set. Let's have a look at an example. This is a default linear layout manager. By using this layout manager, you can show the item sequentially. Another one is grid layout manager. Then you can show items in a grid, like the video on the right. Or you can show the item in a staggered grid, like the video on the right, by using staggered grid layout manager. There are 3 default layout managers provided by the RecyclerView library itself. Then the question comes to my mind, is it possible to add a custom layout manager? Yes, actually it's possible. And I built a Flexbox implementation as a layout manager, like you can see on the right. And the library is on GitHub. If you are interested, you can check it out if you are interested. Also, as a side note, the library got more than 10,000 GitHub stars a couple of months ago. Thanks for supporting it. Thank you. Basically, the library brings the Flexbox specification in CSS into Android. But in this talk, I don't talk about in details about the library. Now you know how, you can create a custom layout manager, but how? I think the important thing is you should think if you really need a custom layout manager before building it, because it's much harder to create a custom layout manager than building a like custom view or custom view group. In my case, the Flexbox layout library I explained earlier has 2 implementations exposed to developers. The first one is Flexbox layout. It extends the view group, and it took me like 1 month to build it. But the other one, Flexbox layout manager that extends the layout manager, took me more than 3 months. So you should know it is much harder than creating a custom view. But once you build it, it gives you much more flexibility you can have your own custom layout. You can have your own custom layout on top of the existing features of RecyclerView, like view recycling, or item prefetch, or the flexible item declarations, and so on. Then if you decide you really need a custom layout manager, first you need to extend the base layout manager, like extending a view when you create a custom view. Then at the bare minimum, you need to override these three methods called onLayoutChildren and scroll horizontally by and scroll vertically by. Let me explain one by one of each method. Let's start with the onLayoutChildren method. This method is called initially when the recycler view is drawn. For example, on the initial layout or when the adapter change attached to the recycler view. Then this method lays out all the relevant children. But I'm going to talk about the, I'm going to explain it based on my implementation. So maybe you don't have to follow all of the steps. But I hope you are going to understand the basics out of my talk. So before going further, let's take a step back to see a unique aspect of RecyclerView. Suppose this is what you can see in your device. But as you know, behind the scene, there are more items in the adapter, and most of them are not visible at any given moment. Then, if the container that holds the items is view group, all the items, including the invisible items, are on memory. Yeah, I know RecyclerView is also one of the view groups, so it applies except for RecyclerView. On the other hand, in RecyclerView, only the visible items should be on memory, right? Which is one of the biggest difference from other view group implementations. Then, considering the fact that the RecyclerView should only hold the views visible in the screen, the onLayoutChildren method first finds the anchor position. But let me explain what is the anchor position. Anchor position is like a starting position to put the views. And on initial layout, it starts with 0. So which means from the anchor position, you will begin putting views. This is needed because the RecyclerView needs to remember the first visible view to restore the state from situations such as like when the screen rotation happens, you need to restore the state from the previous state. Or when the user presses back button, you need to restore, and the user backs to the app, you need to restore the previous state. So you need to restore the previous state and remember it as an anchor position. Then it calculates how many items should be in the visible portion. Then starting from the anchor position, the method fills the views towards the towards the end direction. In this case, starting from the anchor position toward the bottom of the screen. This is the very simplified version of my fail method. And yeah, don't scare. You need to understand every step of the code right now. But I want to give you the overview of the method. There is an argument that has the amount of pixels that need to be filled. Aim available is used for that purpose, and the direction that represents whether the method is feeding the views toward start or end. Then in the while loop, it put the views until the available space becomes 0. It means the amount of pixel needs to be fully filled by this method. The important thing is it is better to make this function usable from other contexts, because in other situations, like when the user scrolls the screen, the same thing happens. The same thing means you need to fill the specific amount of pixels. So it is a better idea to make this function generic and can be usable from other contexts. Then similarly, from the anchor position, it fills towards the start. Then in this case, from the anchor position towards the top of the screen by using the same fail method with the opposite direction. Then maybe some of you may be wondering why it fills toward both directions, toward both bottom of the screen and the top of the screen. Because in some cases, anchor position may be at the bottom. Let me explain why. For example, let's assume you have a screen like this, and please assume the gray rectangle is the visible portion of the device. Then scroll to position method is called, which means the layout manager needs to scroll it until the 50th items becomes visible. In that case, it is natural to put the 50th item at the bottom once that item becomes fast visible. Is it clear? Okay. Then in that case, anchor position, it is natural to put the anchor position at the bottom, then start filling the views towards the top of the screen. Okay, that's it about the on-layout method. The next method you need to implement is scroll vertically by. Basically, it interacts with the scroll by the user. First, you need to override this method. It represents whether the layout manager supports vertical scrolling. When you return true, it means the layout manager supports vertical scrolling. But maybe it could be false depending on the attributes. For example, if you imagine linear layout manager, whether the linear layout manager can scroll vertically depends on orientation, right? So it doesn't have to return true always. Then here is a simplified version of scroll vertically by method. Likewise, you don't have to understand every step of the code right now. But to highlight some important aspects of this method, the distance to scroll in pixels is passed as an argument. This is actual distance that the user is trying to scroll. Then the actual distance scrolled is returned from this method. Then let's have a look at how this method works visually. If the delta y, the scroll distance is small, then the method should only shift the existing views, right? In this case, you can simply call the method called offset children vertical. Then that's it. But if the delta y is large, then you need to treat the other situations in addition to shift existing views. First, you need to recycle views that are no longer visible. And you need to fill appearing views to fill the gap. For filling the gap, you can use the same method, same fill method you used in the onLayoutChildren method if you build it properly. But I haven't explained about what does recycle mean. In RecyclerView, there are two types of cache. And the first one is recycle, and the second one is scrap. The first type, recycle, within the RecyclerView, there is a component called recycler, which manages the cache in RecyclerView. Then when a layout manager calls RecyclerView, the view is stored in a component called recycled view pool. And the views stored in recycled view pool are considered as dirty, which means the views are needed to be rebound by the adapter before returned to the layout manager. Also, another aspect of recycled view pool is it can be shared across multiple recycler views if you want by attaching the recycled view pool to another recycler view. Okay, the second one is called scrap. This is considered as a more lightweight cache. When you call scrap view from layout manager, but actually that method is package private, so probably you need to call the method detach and scrap attach the views to scrap the views. Anyway, if the views are scrapped, the views are stored in a place called scrap heap within the recycler. Then, unlike the recycled view pool, scrap heap can't be shared across multiple multiple recycler views. Then, given how the cache works in RecyclerView, how you can retrieve a single view. The layout manager usually retrieves the view through the recycler. Like the layout manager calls the method getView for position. Then there are 3 cases depending on whether the view is found in the cache. Or to be exact, there are more cases, but to simplify it, let me use these 3 cases to easily understand it. The first one, if the view is found in scrap, then in this case, the recycler is going to return the view without going through the adapter again. So as you can imagine, this is considered as a very cheap operation because the view isn't need to be created or even isn't need to be rebinded by the adapter. The case 2, if the view is found in recycled pool, then as I explained earlier, the view is considered as dirty in that case. So the view needs to be rebound by the adapter. So the recycler needs to call the bind view holder. This case is also considered as lightweight, but not that light compared to the case 1. Then the view is returned through the recycler, like the image. And the case 3, the view is not found in cache. Then in this case, the view needs to be created through the adapter from the beginning, and then returned through the recycler. Now, as you can imagine, this is considered as a very expensive operation compared to the previous 2 cases. So you need to make sure it doesn't happen frequently in your layout manager. The takeaway from it is a better idea to scrap your view if you reattach your view in the same layout path. In other words, in the same method, and use recycle for views that are no longer needed. All right, that's it about the scroll vertically by method. And for the scroll horizontally by method, it is basically the same, except for the direction that it is trying to scroll. So if you understand the scroll vertically by method, you can implement this method in a similar way. All right, then you implement the basic functions. So is it enough? Well, it could be usable. Then basically you can render the views and you can scroll the views, but it can't be used in a production because there are a lot more to implement before publishing it as a stable version. But the most important part is if you understand the basic concept of how recycling and retrieving a view works, the rest of the features are not that hard to implement. But out of these features, let me explain predictive animations, because it may be hard unless someone teaches you what is it. By the way, how many of you have heard about predictive animations in RecyclerView? Okay, yeah, I hope this is going to be a good explanation. Okay, let's compare the behavior first. There are videos on adding a view. If you look at the video on the left, which is predictive animations of, the views that are going to be invisible at the bottom are disappearing suddenly, right? Which may look unnatural. But if you look at the video on the right, the views that are going to be invisible are sliding off the screen instead of disappearing suddenly. Now, this is the case where predictive animations is on. And I think the right one is better, right? Also, there are videos of deleting views likewise. If you look at the video on the right, the new views are appearing instantly, and which may look unnatural and which may be weird. On the other hand, if you look at the video on the right, the new views appearing are sliding out of the screen, right? And which looks more natural. This is the behavior of predictive animations. Then to support this behavior, first you need to return true in the method called supports predictive item animations. Then you need to change the on-layout children to do pre-layout in addition to the real layout. Real layout means what I explained earlier. Pre-layout is what I'm going to talk about. Okay, in pre-layout is a layout phase where the layout manager lays out all the views currently visible and additional views that are appearing or disappearing after the animation. If you can understand from the sentence, you are too smart and you don't have to listen to me. But let's take a closer look at how it works visually. Suppose you have a layout that looks like this, and you are going to insert a new view at the middle of the visible portion. Then after the insertion, the view marked as red is going to be disappear. So the view marked as red is not need to be drawn in the real layout, but in pre-layout phase, you are going to lay the views, including the red one. Then in the real layout phase, the view is sliding like this. Then the new view comes here like as a green one. Likewise, if you are going to delete the middle of the view marked as green is currently invisible. But in pre-layout, you need to lay out all the views, including the green one, so that in the in real layout phase, it is sliding outside of the screen, right? It is what you need to do in the pre-layout phase. Okay, that's it about the predictive animations. Then now, I hope now you know the basics of the building a custom layout manager. Also, here are useful resources that help you build custom layout manager. And I will be around for the rest of the conference. If you have any questions, please catch me or please ask me any questions. All right, thank you for listening to my talk.